Hello. The beard left me. It's gone. Short beard now. I got tired of Tybalt chewing on my face all night, so chip, gone. It left. I said go, but now I kind of miss it, so I put up like, have you seen my beard posters around Hamden to see if somebody can find it and bring it home. I'm sure it's cold and scared out there. I was really out of line with that. Anyway, today we're going to be talking about dependency management. How exciting is that? And then there'll be some other smaller supplemental videos to show you how things go and show you how it works. But for now, I'm just going to talk about, for this video, we're going to talk about conceptually what are dependency management systems. Also, we're joined as usual by Jules down here to my right. Uh, Sunbathing. So not in his usual spot, but you know, even the best cat in the world can't refuse a good sun spot. Am I right, dude? That's right. Anyway, let's get on with it. Doot, 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 doot. Ah, wait. What happened? But it uh, I I checked you. Boop. Ha ha ha. Excellent. All right. So here we go. Dependency management. I made this. You guys remember this meme? Uh Very little software. It's just made from complete total scratch, right? It's very rare somebody just with a computer disconnected from the internet with Python or C++ or whatever installed just starts hacking away and create something, right? Most, if not nearing all software that's made these days is made with the use of dependencies or libraries or things we're going to talk about on this page. So let's go over some definitions. These definitions, you will actually hear all three of these used somewhat interchangeably by people because they're all describing very similar things. So it's kind of awkward to keep them really separated in your mind. Um, Libraries is a generic that's sort of a generic name for software that's just written purely for the consumption of other developers. It's software that's written and it doesn't have a user interface. It only has a programming interface. It's just basically a tool that other developers, software developers wrote so that other developers can do a particular thing, whether it be render 3D images, make calls over the network, or read in certain kind of files, or access certain kinds of databases. They're very kind of specific things usually. An application programming interface is a kind of library that, well, not a kind of library, it's a kind of dependency. It's a thing that usually, if there's a product, like software out there that exists that people use, like normal people, not our kind of people. If it's software that normal people are using that has like a graphical user interface and things like that, an API is typically another interface that's provided for programmers to make use of the technology that real people are. For example, Google Maps has an API where you can do everything a human does, but through lines of code rather than having to like write something that fakes mouse interactions with a map or something. And things like Facebook, uh, like there's weather API. There's APIs for pretty much everything you can imagine. Discord has an API, and that's how our bots are powered. We make a bot and we make calls into the Discord API in order to implement that stuff. And if you're really splitting hairs, technically the Discord API is a web service that's hosted, and then you can download a library that talks to the Discord API. So that's like kind of two things. There's a web server running that services requests, and then there's software you can download for your language of choice, be it Python, JavaScript, Java, so on and so forth, that will help you more easily make calls to that interface. You could actually, in any language, just write some HTTP requests to go hit the API for Discord, but people have made that easier, and generally it's a good idea to use those because it just saves you a lot of work. Frameworks are kind of like collections of libraries. You kind of think of them that way. A framework is a collection of libraries brought together for one unifying purpose. For instance, what we're going to be using in this class is a web framework. You can use a web framework of your choice. I'll be teaching everyone Django, which should probably make it one of your first choices because everyone on your team will be familiar with it. But in case everyone on your team is familiar with Play framework, then you guys could all use that or Spring or whatever. But we'll be teaching Django, and I think probably most of you will be using Django for your project. Just as this is a popular one that we chose, so I'll teach it to you guys. But once you kind of learn how to use one web framework, there won't be many curveballs in other frameworks. All of these things are considered dependencies. Why? Because your code depends on them for its function. So they're dependencies. Can't run your code without, if your code uses a library or an API or a framework or any of these things, it can't work without them, right? So it's dependent on them for its function. So they're all dependencies. So how did we deal with dependencies in the past? It was a dark time. What we used to do is just like go to random nerds' websites where they had hosted their library, and it would just say, "Hi, my name's Tanya. I wrote this software for, plotting data sets. Here's a link to download." And it's like, well, Tanya seems very nice, but do I really do I trust this website that's just like kind of text and stuff? So it wasn't really trustworthy. So no matter who you were downloading software from, it just felt a little suspicious. Also, you didn't really have a sense of like how many other developers were using that software, which is actually really important. Nowadays, when for the dependency management systems that we're using now, you can look at a library and the dependency management system will tell you how many times it's been downloaded, which is a big deal. If it's being used by 5 million software developers, it's probably not filled with malware. Probably. Or it's well-hidden malware. Do I have to package all the dependency code with my software in order for it to be? Yeah. So what would happen is you'd download all this code, you'd add it to your project, kind of like as if it was your own code. You just install it in there, and then your project would just be huge because you'd have like your code, and then you'd have all this code for your dependencies. And so if you had a new developer join your team, they'd have to download this massive thing to get it to work. And it was annoying because it could become unclear where the actual code for that project was because there'd be all this other dependency code everywhere, and you'd be like, well, our code is actually in these two folders. It's like, what? It wasn't ideal. And because it wasn't ideal, we the community innovated, and now we have some nice dependency management systems. Except for C++, I haven't found one for C++. If you find one for C++ that seems to be in wide use, please let me know, because for some reason I have been unable to locate it. So let's talk about a couple sample dependency management systems. One is Maven. Maven is in use by Java. It's also there's a bunch of different technology that uses it. Gradle uses Maven. But you think of Maven as sort of the GitHub, but for already like usable stuff. So you get a file called it's a pom.xml. You would put it in your Java project, and then you basically just list out all of the dependencies that you want in this scary XML file, and then run this Maven software, and it would install all of them. And so what's nice about that is that you could download a Java project, and if it had a POM file with it, you could run Maven, and it would install all of the software that that project wanted. So you would still, in your project folder, only have the code for that project, and Maven would install the things it needs elsewhere so they're not in your way and distracting. You could still go look at them, you still have references to them, but it wasn't like 98% someone else's code and then you're trying to develop that 2%. And Maven works reasonably well. It has its hiccups, it has its problems, but it's a pretty nice way of managing dependencies. Python has another okay way of managing dependencies, and it's just weird. It's a bit weird, but it's not that weird, and we'll figure it out. So the Python dependency management system is kind of like an amalgam of a few different technologies. So uh, PyPy is kind of like a repo out on the internet where a lot of dependencies live. Pip is software that lets you access those dependencies. And so is Conda, so they're kind of competing ones, and they work slightly differently. And then there's also a virtual env, which does this completely separate thing. So let's talk about these for a second. Virtual environments. So in Python, when every time you make a new project, the standard practice is to make a virtual environment for that project. And what that means is basically copying you're basically copying your Python installation folder someplace else, and then why it's an environment is the virtual environment takes all the pointers to your Python install and points them to this copy of it instead. Therefore, when you install dependencies, they are installed on the copy of your Python install rather than your system Python install. Why would you do it that way? Well, you don't want to clog up your system Python install with a bunch of excessive. You want to keep your system Python install pretty small. Because when you say I have one project that uses 50 libraries and one project that uses 5, I don't want the project that uses 5 to have all 50 of these things available. It's consuming, and it's consuming. It's confusing, and it can also cause like some conflicts and things like that, and you probably just don't want to do it. So this is the Python way of solving this problem. When you download or start a new Python project, you basically get a fresh Python install for each one of those, which is just a copy of one of your system installs. So PyPy is a repository, much kind of like GitHub, but it's a little different. What PyPy does is it has all these software projects hosted, but not only are the projects hosted, but also information on how to install them. So that software like pip, you can use pip and you can say pip install, then the name of your library, like requests. And what it'll do is it'll contact PyPy, download the code for that library, and then also install it in case it needs to actually have access to different parts of your system. Pip will help you install that. So all of these things together work in concert to help you be able to download libraries on which to base your software from. Let's just do it. So the next few videos you're going to see in the playlist for this class are going to be demos of how to use Python dependency management. So I'll show you both how to use Python dependency management from the command line, and then I'll also show you how to use it using PyCharm for those of you who are using PyCharm as your Python IDE. All right, so that's it for this video. See you in the next one.